Welcome to this video tutorial on geometry proofs involving triangle congruence. We are going to go through 3 proofs in this tutorial. The speed will move kind of quickly, but please pause the video when needed. You have the ability to pause, to replay it, so please take advantage of those options. Each of these problems are problems we discussed in class, but this way if you want to hear them discussed again, and points of emphasis, you can see them and hear those points of emphasis. Here's our first problem. Pause the video if you need to copy it down. What we are going to do is label the picture. We've labeled the picture with our givens, and sometimes it helps to draw the triangles out separately. So we're going to look at triangle AWY and triangle ZWX. Now when we look at those triangles, we already have 2 pieces of information that match up between them. We've got these green angles in the lower corners, and we've got the fact that AW is congruent to WX. And actually for step 2 in our proof, we are going to go ahead and write the fact that AW is congruent to WX. Make sure you put those segment bars on top, make sure it's a congruent symbol, and that's going to be the definition of the word bisects. So definition of bisects. Step number 3. What's another thing that we can get in these triangles matching up congruent? Well, we emphasize this in class. Make sure you have it down. Make sure you know what to do with it. These 2 triangles overlap at this angle ZWY. So we're able to say that angle ZWY is congruent to itself. And we know that anything is congruent to itself because of the reflexive property. Well, now, once we have said that that part where they overlap is the same, these 2 larger angles that I've just highlighted in blue, which are these angles in the smaller triangles down here, it's angle AWY and angle ZWX, they have to be congruent. And angle AWY and ZWX must be congruent because of the overlapping angles theorem. We have shown that the part where they overlap is congruent to itself. So since the smaller angles are congruent, the larger pieces have to be congruent as well. As we stressed in class, those steps 3 and 4, the reflexive and the overlapping angles theorem, must appear in tandem. Please do not have one without the other. Then, at this point, we have enough to prove that the 2 triangles are congruent. Now make sure you name them appropriately. You can name the first one however you want, but if we use A as the first letter, then in the second triangle, X has to be the first letter. Then we go to W, and last but not least, we would go over to Z. Which one of our triangle congruent shortcuts tells us that those triangles are congruent? Well, that's 2 angles with the side in between. Angle, side, angle. Then please specify the steps in which we obtained the information. Our side was in step 2, that's the magenta side. One of the angles was the green angle given to us in step 1. And last but not least, we got those blue angles worked out in step 4. Now that we know those 2 triangles are congruent, it should make sense to us that ZW, the last 2 letters, are congruent to YW, the last 2 letters. Please name it as you are asked to name it. ZW is congruent to YW. Make sure the segment bar is on top. And the reason we know that if the triangles are congruent, those pieces of the triangles that match up must also be congruent? Well, that was what we called the polygon congruence postulate. At this point, we are done and we are happy with the first proof. Let's move to the second. So here is the second proof that we are going to consider. It's another proof that we did in our notes. If you want to pause this video to copy it down before we discuss it, please do. But we are going to proceed to going through it. So let's label our picture. Here it is, and let's try to prove this. First, because the red sides are congruent, because those 2 pieces of the triangle are congruent, if the sides are congruent in a single triangle, the angles across from those sides are also congruent. So in step number 2, based on what I've just colored in magenta, we're going to be able to say that angle DAC, the bottom left angle in its entirety, is congruent to angle DCA, the bottom right angle in its entirety. Also, because of the fact that the two blue sides are congruent, we're going to be able to get that angles 3 and 4 have to be congruent as well. Both of those pieces of information rely on the same reason. And the reason that we know if two sides of a triangle are congruent, the angles across from them are congruent, that is the isosceles triangles theorem. Please also specify what step we looked at. Here, we looked at step 1 to obtain that information. Now, what we're going to do is we're going to say that a part, the measure of angle 1, plus a part, the measure of angle 4, is equal to the whole thing, which is the measure of angle DAC on the left. Part plus part equals whole. Make sure you've got the m in there for the measure of the angle, and make sure it's an equal sign. We'll do the same thing for the the right-hand side. The measure of angle 2 plus the measure of angle 3 is equal to the measure of angle DCA. That was the angle addition postulate, and we did that a lot back in Unit 2. Angle addition postulate says the part plus the part equals the whole thing. Now, before we can substitute, we have to take step 2, and we have to change it from the angles being congruent to their measures being equal. So we'll be able to say the measure of angle 3 is equal to the measure of angle 4, and the measure of angle DAC is equal to the measure of angle DCA. The reason we know that if the angles are congruent, their measures are equal is the definition of congruent angles. Step 5. Now that we've said that, we can substitute. So we're going to rewrite the equations in step 3 and make two changes. We're going to rewrite the measure of angle DCA in the second equation as the measure of angle DAC. And in the second equation, we're going to rewrite the measure of angle 3 as the measure of angle 4. Everything else is going to remain unchanged. So the first equation, we just rewrite it, copy-paste it directly. Second equation is going to become measure of angle 2 plus the measure of angle 4, we're making that substitution, is equal to the measure of angle DAC, we're making that substitution. Remember that as long as the substitutions come from the same step, we can do them at the same time. Scrolling on to step number 6. Notice that the two right-hand sides of those equations are the same. Letter for letter, symbol for symbol, word. So what we can do, since the two right-hand sides are the same, we can set the entire left-hand sides equal. Not just pieces of them, but the entire left-hand sides equal. Measure of angle 1 plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 4. This was a common reason back in Unit 2. It's the transitive property. Make sure you know that reason. Now, we can subtract angle 4 from both sides. We get the measure of angle 1 is equal to the measure of angle 2 after subtraction. And last but not least, we don't want to end up with the measures being equal. We want to end up with the angles themselves being congruent. So we can say angle 1 is congruent to angle 2. And now why is it the case that if the measures are equal, the angles are congruent? Well, that's just the definition of congruent angles. You can't do this proof in fewer steps, but you might do the steps in a different order. This is one option. Now, we went over a second way to do this same proof in class. And it's so important that we're going to do it in this video tutorial as well. What we said in class was that we could simply connect points D and B. We've seen other examples like this as well. You don't have to say that you connected them. Just in your proof, tell us that segment DB is congruent to segment DB. Anything is congruent to itself because of the reflexive property. Then, at this point, we would have enough to say that these two triangles, DAB and DCB, are congruent. So triangle DAB has to be congruent to triangle DCB. The reason? Well, side, side, side. Two of the sides are given to us in step 1. The final side was the reflexive side we got in step 2. Well, now since those triangles are congruent, it should make sense that the angles in those triangles are congruent as well. So angle 1 would have to be congruent to angle 2 because of the polygon congruence postulate. That was a much faster way to do the same proof. There are multiple ways to do the same proof many times. It's just faster if you see how to do it this way. But please be prepared for these ideas. A lot of the proofs that we're going to see, even on a test, are using the same or very similar strategies to ones we've discussed in class. So with that being said, let's do our third and final example. It's another proof that we've looked at in class. If you want to hit pause on the video to copy it down and try it before we discuss, please do. But now we are going to continue and actually try this proof. So let's color code our picture and see what's happening. Now when we look at this picture, there's going to be a couple other items that we will use in order to prove that this works. First of which is we've got these vertical angles here at angles 3 and 4. Those should work out to be the same. Secondly, based on the fact that angle 1 is congruent to angle 6, we should be able to establish that angle 2 is going to be congruent to angle 5. Now, as we said in class, in the given, we need to write when we have a linear pair. So we're going to say angles 1 and 2 form a linear pair. Abbreviations are fine. And angle 5 and angle 6 also form a linear pair. And again, abbreviations are fine. So now in step 2, what are we going to do? Well, knowing that things form a linear pair means that they are going to add up to 180 degrees. A common strategy back from Unit 2. So we're going to say that each of those pair of angles add up and measure to 180 degrees, and that's the definition of a linear pair. Step 3. Well, we also know that angle 1 is congruent to angle 6, so we have to convert that. We're going to convert it from saying that the angles are congruent to their measures themselves are equal. So measure of angle 1 equals the measure of angle 6, and that's the definition of congruent angles. Before you substitute, you have to do that step. But now, we can simply change angle 6 into an angle 1. You do not have to do things in this order. But in this case, it's the order that I'm deciding to do them. You might have done it in a different order. That's fine. And that was just substitution. Now, notice the two right-hand sides are exactly the same. So we can set the left-hand sides equal in their entirety. Make sure you set the entire left-hand sides equal, and that's our transitive property. Now, we can just subtract the measure of angle 1 from both sides before we proceed. And after we subtract the measure of angle 1 from both sides, we have to then convert it from the measures being equal to the angles being congruent. Okay, so that took care of those angles up there, angles 2 and 5. We also need to get into this proof that angles 3 and 4 are congruent. And angles 3 and 4 were congruent because of the vertical angles theorem. You do not need to tell me in the given that they are vertical angles. Just use the fact that they are congruent, and you'll be good to go. Step number 9, we can say that triangle ABC is congruent to triangle DEC. The reason? Two angles with the side included in between. So we say that we've got the triangles congruent because of angle side angle. One of the angles was in step 8, another angle was in step 7, and I believe the side was given to us. Yep, it was up there in the given. Last but not least, because those triangles are congruent, it should make sense to us that AB is congruent to DE. That's the first two letters in each triangle. So since the triangles are congruent, their corresponding sides must be congruent as well. AB is congruent to DE, and that is because of the polygon congruence postulate. So at this point, the proof is done, and just please be aware, in the given, say that you've got a linear pair, and then just keep track of things as you go.